All right, so next to number 1, write down the words parent function. So how many of you guys have heard that vocab before? Parent function. So parent function is kind of the simplest version of the function. Nothing is adjusting it. Notice that it doesn't have any constants being added or subtracted, no numbers multiplying the quantity. It is just the most basic version of x with absolute value bars around it, so you can see what absolute value does to graphs. So when you put this into the calculator, this is the graph you get. So notice, our absolute value graph should be shaped like what? V's. So every time you see an equation with absolute value in it, your graph better look like a V when you're done, right? Notice that the vertex of this graph specifically, the parent function, is at 0, 0. It opens upward, and that the two lines both go up 1 over 1, just in different directions. Okay? So then how did they figure out these numbers right here? So remember our formula said a x minus h and plus k. And then the equation they gave us in this problem just had x inside of here. So the way they figured out a, h, and k is if there's not a number written in the a spot, the number that's there is the number that can multiply stuff but doesn't change the outcome. So what number in our system has a property that it can multiply stuff but it doesn't change the outcome? 1. So it's really like this is being multiplied by 1 if we don't see it there, right? Now, h is being subtracted from x, and k is being added after the absolute value. What number has the property that it can be added and subtracted from stuff and not change them? What's that? 0. Good. So it's like there's a minus 0 here and a plus 0 here. We don't see those things because they don't change the outcome, but that's how they determined a is 1, h is 0, and k is 0. They thought about what numbers had to be in those spots to make the equation look like this in its simplest form. So when we look at something like number 2, what are you guys going to fill in for the a, h, and k values? What's the a value going to be? 3. What's the h value going to be? 0. And the k? 0. Okay, so go ahead and write those in. And then what you're going to do in the next spot is you're going to make a sketch of the graph. Sketch. Am I asking you to be super specific in your points? No. Basically, we're trying to investigate what does changing the a value from a 1 to a 3 do to the graph. So you're going to use your calculator to quickly get the graph and make the sketch for you. So you're going to be able to do this with all of them, and you can split the work up within your groups. For your calculator, again, you guys already have had Algebra 2, so you should be a little bit familiar with this, but some of you guys avoided the calculator altogether, right? So go into y equals, and we're going to clear out and turn off anything that's on in there. So any equation that's already in the y equals, just press clear on top of it. If you have anything at the top that's highlighted, the plot 1, plot 2, plot 3, like you can see on my calculator, plot 1 is highlighted. I don't know what somebody was doing, but they were graphing plot 1. I don't want that right now. I'm going to go up there, press enter on top of it, go back down, and now it's not highlighted. Okay? So nothing's being graphed that I didn't say to graph right now. What I want to type in is 3 times the absolute value of x. So I'm just going to type a 3. And then I need to go get the absolute value function. Okay? Does anybody know what button on the calculator houses the absolute value function? Math. Good. Okay. So math. Reminder for those of you that don't remember, go over to the right one menu to num, and that number 1 right there is the absolute value function. Now, when you type it, one of two things will happen. Either you'll actually get absolute value bars like I have up here. Okay? If that's the case, we just want x inside of our absolute value bars right now. So I just type x inside of there. I scroll back out of there, and I'm done. If yours didn't type the absolute value bars, then it literally typed what you saw when you went into that menu, A, B, S, and a parentheses. That's the same thing as having absolute value bars. You type in your x, and you close the parentheses, telling it that's all that you want inside the absolute value bars. Okay? All right, now we want to go graph this, but you guys saw weird stuff was in the calculator because people were graphing other things. So we want to get our window back to a pretty basic window. So before I go to my graph, I'm going to go to the zoom button, and I'm going to zoom back to the standard, like 10 positive, 10 negative in each direction window. Okay. So I'm going to press zoom, and I'm going to choose choice 6, which is standard, and here's a sketch. So you would go ahead and make this sketch on your paper for number 2. Okay. Remember, just a sketch. Okay. What is the difference between this graph and the parent function that you see in graph number 1? Yeah, it's skinnier, right? So what the 3 did is it changed it from this to this. It made the line steeper, or it made the V skinnier. You just want to pay attention to that as you go through the numbers, because the goal is for us to finish this activity and say, okay, I don't need the calculator. I can graph it just as fast as the calculator can by recognizing A, H, and K and knowing that they do these specific things to the graph. Okay? So we're going to give you guys a few minutes. You have 5 more of these to do. Okay? For number 2, the vertex should still be at 0, 0, right? It's still hitting right at the origin, and it's still opening up. So you guys should finish number 3 through number 7. You can split the work up in your groups. If someone doesn't have a calculator, they can do all the A's, H's, and K's, and then you guys can let them copy your sketches. Okay? Whatever you need to do to get this done in the next, 5 minutes or so. Okay? So you guys can see your calculators. So let's just check that your values are right and try to summarize what's happening. So in number 2, we already talked about that we should have a 3, 0, 0. What should be your A, H, and K values for number 3? Okay, H and K should be 0, 0. And then I heard -2 for A. Okay. So there's number 2 and 3. So 2 and 3 focused on the A value. So somebody summarize for me, what changes did you see happening when we were just changing the A value? Because when I'm graphing by hand, I want to know when I see a number there, what kind of change to expect to see on the graph. Lila? Okay, so first thing I see is that if the value is positive, it's opening up, but if it's negative, it's opening down. Okay? What else? What about when the number changed from 1 to 3 or from 1 to 2? What did you guys see? Okay, good. So A is controlling 2 things. The positive negative part of A is controlling whether we're opening up or down. And then the number part of A is controlling whether we are more narrow or wider than the parent function. Okay? So on the back side of this paper, or on the second page if you printed it yourself, it has some questions. Okay? First part, how can you predict whether the graph of the equation will open upward or downward? Okay? So upward is going to be if A is bigger than 0, or in other words, if A is positive. Okay? It's going to open downward if A is smaller than 0, or in other words, if A is a negative value. Okay? So that's kind of what we saw happening, or what you guys said was happening. Then how does changing the value of A affect the graph? So we're going to treat the positive negative part of it just like in Algebra 2. You guys treated it differently. That determined reflections. Right? And then the numbers determined stretches and compressions. Okay? So this controls the width of the V shape. Or basically, it's going to be treated like slope of those lines. But you can't make both the lines going on forever and ever like an X. It's got to look like a V, but the A number is going to help you control the slope within that. All right, then go back and look at numbers 4 and 5. What value were we changing when we were looking at the equations in number 4 and 5? Luke? Okay, yeah, good. Where y went in your vertex point, right? So in these ones, you guys saw the y coordinate change in your vertex point. Okay. Why was that changing? What about the equation was changing the vertex point? The k value, right? So here our a's were still 1. Our h's were still 0 because there's nothing being added or subtracted inside of the absolute value with our variable of x. However, after the absolute value is completed, here we have a 1 shifting our function up 1 and a -4 shifting our function down 4. Okay. What you should have seen here is that the vertex in this one became 0, 1. Okay, so it took the whole v and just kind of moved it up a spot. And then the vertex in this one became 0, -4, which took the entire parent function v and just kind of shifted it down 4. Okay. So on that back page, when you look at, after we talk about A, talks about H and about K, we were just looking at K values So how would you guys summarize to somebody what changing a k value does to your graph? What did it just control? What did you guys say happened? Okay, so it's moving your graph up and down, okay, and it's affecting the y coordinate of the vertex. So this is going to shift up and down, depending on whether k is positive or negative. And it also gives you the y coordinate of your vertex. So H is a little bit trickier. So in numbers 6 and 7, A and K didn't change from the parent graph, but your H value changed. What is your H value in number 6? Okay, -3. I know it's weird, but remember what the formula looked like. The formula said A, and then inside the absolute values, it said X minus H, and then plus K. So think about if you're working inside these absolute values, if you have to write X minus, and after that minus sign comes the H value, if you put a +3 inside of there, then your absolute value bars would have inside of them an X minus a +3, and it would just look like X minus 3. That's not what this looked like. Okay, this looks like a plus. The only way that this got transformed to a plus was that somebody was trying to do X minus -3, and the minus, the negative became like a plus. Okay, so the H value here is -3. What is the H value then in number 7? Yeah, +2. So the stuff that's affecting the X, the changes that are happening within the function, in this case the H values, are a little bit wackier than the stuff happening outside, right? Outside, what you see is what you get. A looks negative, it's negative, okay? K says +1, it goes up 1. This is a little different. It said X plus 3. Our H was actually -3, and the vertex that you should have here should be -3, 0. Okay, this shifted our graph to the left 3. And that's why they write it like this, is because they know that when you graph this happens, that it shifts to the left 3. So they want you to get H is -3 so you understand it moved to the left. And then here, when H was +2, you should have seen your vertex show up at 2, 0. So for the H value, this is going to shift our graph left and right. And it's controlling the X coordinate of our vertex. Okay. Is that okay with everybody? Review, or maybe you saw things that you didn't quite know before, just depending on where you were in Algebra 2. So we can graph these quickly by hand if we can pick out the A, H, and K values. What piece of information, if someone gave us an equation, are we going to use to put the first point on the graph? So let's look at the problems right below this. Here's one. Okay, you can see it on the back. It has a graph. I know up here it's a little hard to see, but just to highlight for you guys, this is the y-axis. It has arrows on the end. It says y. This is the x-axis. So if we want to write the equation of this absolute value function, one, I know it's an absolute value function because it's shaped like a V. Okay. So I know my equation should have absolute value bars in it, and it should fit some sort of thing like this. So then to write the equation for this, I need to know the A, the H, and the K. Here is your vertex point right here. Remember, the parent function had a vertex point at 0, 0. Okay. So this graph has been shifted 2 to the right, and then up 1 to get our new vertex that's here at 2, 1. And remember, H is controlling the x coordinate, or is what we shifted horizontally, and K is controlling the y coordinate, or is what we shifted vertically. So I know from this vertex point that my H value should be +2, and my K value should be +1. Should my A value be positive or negative? Positive. How do I know? Good, because it's opening up. Okay. And so then I just need to take one of those lines and look at the slope. So this point, to get to another point on the line, would go up 1, and it would go over 1, 2, 3, 4 to pass through another point. Okay? So the slope here would be a rise of 1 and a run of 4. Now, if you did it the other way, the slope would look like a negative 1/4. But again, we're not using the V to determine if it's negative or positive, because one of these is always going to have a positive slope and one's always going to have a negative. You're going to use whether the V is up or down to determine whether you put a positive or a negative with your A value. Okay? And you guys already said it faces up, so I'd want to keep this positive. So my equation would say y equals 1/4 x minus 2 plus 1. Is this all right with everybody? Okay. And I know for some of you this is like massive review. For others of you it's like, oh, I didn't get that before, and now I get it. Okay. So just try to be patient, because a lot of the things all of us have seen before, some of us more so than others. Okay. All right. Then let's graph 1. Since you guys have seen a lot of these before, let's do this one that's on your paper together. So I just want to address this one, because this one is not set up as the A, the H, and the K. What's the matter with having it that way? Sean? Good. Okay. You don't want inside the absolute value bars 2x minus h, right? That's not what the formula said. It said I want x minus h, and I don't want anything multiplying x. So the first thing I have to do is within the absolute value bars, I need to factor out that 2. But I can't just separate it from x. Okay, I have to separate it from every term that follows that's also within the absolute value bars. So I'm factoring the 2 out of the 2x, but I'm also forced to factor it out of the minus 4. Okay, so that's going to leave me with 2 times x minus 2. Is that okay with everybody? You can see if you multiplied it back out, you would have the same thing that we had before. So there's an interesting property that happens with absolute values. So this is not going to happen in the rest of our functions. In the rest of our functions, we're going to leave that number inside of the function, and we're going to decide what it does, and that is something you didn't do in Algebra 2. And that's going to happen at the end of this week and beginning of next week, so we can see how that affects the graph, and then we're going to do it with everything from here on out. Okay? With absolute value, we don't have to do that, because let's think about if you were doing negative 3 times 5 inside absolute value bars. Okay, so you multiply it, you'd get negative 15, and then you'd turn it positive, right? Would you get a different result with the multiplication if you had taken the absolute value of each number before you multiplied them together? Will the answer to this second problem be different than the first problem that I wrote? No. Because in the end, it doesn't matter the order you multiply the 3 and 5, you're always going to get a 15, right? And because absolute value turns it positive, it doesn't matter if you turn it positive at the end or before you get to the end, because multiplication works the same. Now, if it was addition, it would matter, right? Because if I did addition here, this would be 2. But if I did addition here, this would be like a 3 plus a 5 and would be 8. But with multiplication, I can separate that. That means that right here where I have a 2, and my 2 is multiplying this other factor right here, this x minus 2, I can do what I did here. These two things can multiply each other, or they can go into their own absolute values. So I can have 2 in its own absolute value and x minus 2 in its own absolute value. I just did what we said we could do over here. The reason that that helps me in this case is because the one that just has the number inside of it, you should be able to calculate the absolute value. What's the absolute value of 2? Just 2. Okay, keep it positive. And then inside my absolute value bars is x minus 2 and then plus 3. Now the equation looks how I expect it to look, where I can pick out my A, my H, and my K. All right? What is my A value then? 2. Okay. Positive 2. What is my H value? 2. Positive or negative? Positive. And then my k value, 3 positive. So remember, these two together create your vertex point. Okay. All the shifting that your graph did. So I'm going to start my graph at the point 2, 3. So you guys can make your own x and y axis and just plot this point. Mine goes totally not find it. All right, and then plot the point 2, 3. Do I expect my absolute value v to open upward or downward? Upward, okay? So then I'm going to use the slope 2. I'm going to think of it as like go up 2 over 1 from the point that I'm at, and I'm going to use those movements to make an upward v. So I'm going to go up 2 over 1. And I'm going to go up 2 over 1 the other direction, specifically to make that v that opens up. Okay? Is this okay with everybody? So you only have to factor out the number if it's inside the absolute value bars multiplying x. Then you have to do these extra steps that we did right here. Otherwise, it's just going to be given to you in the format where you can see your a, your h, and your k already. Is this okay with everyone? Okay, so then what I'm going to have you guys do is instead of filling out